Welcome back. In this video, we're going to be taking a look at how we can build out a lithium-ion battery pack that we can use as a flight pack. And so what we'll do is take a very quick look at some of the things that we're going to need in order to be able to do this build here, and then get into it. Of course, when you're doing this, you're going to need to have the cells that you're going to be using. I'm using Molicel P45B high drain cells for this. You will need to have your balance lead put on there, the actual power lead, and the XT60 connector. You will need to be able to make connections between the individual cells, so you can make them, attach them and connect them in parallel and in series. Typically, a lot of people would use just 16 gauge silicone wire, which will be perfect for it. What you can also use is nickel strip. So this is a long roll of nickel strip. You can also buy individually pre-cut pieces of nickel that are designed to fit just across that gap between the space of two cells. You'll need a pair of just general side nippers, wire stripper and cutter. Because I'm soldering, I always have a pair of these cross-lock tweezers around. They're just amazing for holding things in place and keeping your fingers cool. I use Fibre tape, just a single direction fiber tape. It's really strong and non-conductive, so it's really good that way. You'll also want to have some Kapton tape. This is a completely non-conductive tape that is used to basically cover connections and cover soldering points to keep them safe. When you're doing this, you absolutely need to have a kind of flux that you're going to be using. It will be your best friend as you go through this. You need flux. Get a no-clean flux designed for electronics, not for plumbing. In this, I'm going to be using two different sizes of solder. Not necessary, but I'm going to. I have here a 20 gauge solder. That's what I'm going to be using on the cells themselves. Because the solder is larger, I'll be able to transfer more solder onto the battery cell and get that process finished with more quickly. If I were to use the other solder that I am going to use for different purposes, you can see it's 22 gauge or 23 gauge, sorry, and it's much thinner. And so for me to get a volume of solder onto the cell will take quite a bit longer and use up quite a bit more of the solder. So I'll use them both, but for different purposes throughout the build of the battery. The other thing you will need, of course, is a soldering iron. Now I have several. I have a normal desk soldering iron, a Hakko desk soldering iron. It's got tips that look like this, and you can see the tip size there. It's about as thick as I can get for this soldering iron, at least that I own. And over here I've got another. This is just an ordinary Welder 100 watt soldering iron. Many people use them, I think, for stained glass. You can see the tip size difference. What matters when we're working with these cells is not how hot the iron gets, because they'll all get up to 700, 800 degrees, but it's more how well can they transfer that heat and continue transferring that heat into the cell. If you're using a very small tip, there's only a very small amount of mass there to hold the heat and to transfer it in, and also to stay hot. So this will lose its heat into the cell very quickly and struggle to heat up the cell completely so that the solder will melt. It will do it, but it will just take longer. Now this iron here will not get any hotter than that one, but simply because that tip has so much more mass, it will be able to transfer the heat into the cell much more easily and get that job done as quickly as possible. We don't want to heat up the cells very much if we can. It'll take a little bit of heat, but it's best to get the job done as quickly as possible without heating up the cell. I would suggest typically at least a 60 watt iron for this. 100 watt would be better. Large tip so that you can just keep the heat available. One more tool. Sorry. We need to also have a multimeter. It's sitting right beside me. You need this. It's the only way to keep things safe and make sure you're doing it right. So get yourself a multimeter, a good one. Okay, enough of that. The nice thing about these cells is we can design the shape and layout of the battery pack as we're as we're designing it, and we can make it to the specs that we need. And so here are just two separate ones that I use for goggles. And see, here's a 3-cell, it's just a nice flat pack, but here's another 3-cell that I made into a triangle. And that's just because I had a pouch where this one would fit nicely, and this one here I had a different place where it would fit nicely. So the two basic ways we can do this, I'm going to make a 4S 2P. So if I'm going to make a 4S battery, what we end up with is a situation like this. Positive connects to the negative, connects to like this, and they just go up in a series. So here's the start of it, here's the end of it in a series. So that would make a 4S 1P, right? That's just 4 cells in series. If I wanted to make it a 4S 2P, what I would do is simply make a second one and then join them. So I would make another 4S battery and then put those together. That's one way that you can do this, and it's a perfectly acceptable, decent way to do it. The other way that you can do it is to put them in parallel pairs. So what here I have is now 4 individual 2p cells. So this is 2 in parallel, negative and negative, positive and positive. Here's 2 in parallel, positive, positive, and so on. So 2 parallel, 2 parallel, 2 parallel, 2 parallel. Now all I need to do is connect them in series. I connect this whole cell over to this whole cell in 1 unit, and then over to this one in 1 unit, and over to that one in 1 unit. And you end up with 4S 2P. They are identical in the end. The electrical system comes out producing exactly the same kind of power. There is no difference depending on which way you put them together. It just kind of helps maybe you understand and can visualize it one way better than the other, or perhaps it allows you to change the layout a little bit different so you can lay the cells out in a different pattern. What I have found on my build is that if I put this together basically in that shape and size, it fits exactly right in the front of the AR wing. Here's a dead AR wing Pro. And if I put that, it fits just perfectly. Just like that. Oh, I crapped it all up. As a nice 4S 2P stack. And so that's what I'm going to do. Is I'm going to first make all of these into parallel packs or parallel cells. So that's going to be a 1S2P, 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 and then I will connect them in series to make a 4S2P pack. Now you're not going to want to watch me doing all of that process. It's going to take a little while. So what I'll do first is just talk about the basic soldering and how to do it, and some of the things to pay attention to, and then I'll kind of do the whole build together. So I've kind of cleaned up the area here and gotten stuff ready. Let's do the soldering and get these cells put together. So to begin, what we need to do is get the cells ready so that we can put the connections on between the two cells. And what I'm going to build first are the 4 sets of parallel cells. So what I'm going to do here, as you can see, I've got these 2 cells, positive, positive, negative, negative. And all I'm going to do is join them together in parallel so that they become 1 cell that has double the capacity. Now, the way I'm going to do that, of course, is tin the cells first and then join them, and I'm going to use little pieces of nickel strip. However, it's very common and very simple just to also use this here, which is I think 16 gauge wire. It's just old motor wire. When I had to trim the wire off of a motor to make it fit, that's what this is. And you know, you just cut a piece that would fit the length from center to center and tin them like you normally would, and just attach them like you would normally attach anything that you're going to solder. The distance from here to here, probably about 3 centimeters, 3.5 centimeters is all you'll need for the wire and for these other pieces. So to do this, I've got my large soldering iron heated up here. It's a bit of a beast, And I've got the heavier solder that I like to use for this part of the job and the flux. Use flux. Use electronics flux. It will make this so much easier for you. I'm going to start on the negative side, so don't be shy with it. Get that fluxed on there. I'll tin it now. Let's get a bit of solder on this. And this is the negative side I'm starting with. If you remember what I said before, the negative is this whole can on there. And so it can take a little bit to get heated up. Now that that cell's getting warm, I want it to melt, not from the heat of the iron, but from the heat on the cell. And you can see how much heat this takes to get going on the negative. Oops. It's because that can is so big. There we go. Let that flow into a nice uniform blob. And we'll head to the next one. All right, so that's melted on there nicely. You got nice blobs of solder on both. I need to tin the piece that I'm going to put on. So I will do that quickly. Again, flux on there. And there you go. So this is where these cross-locking tweezers come in handy. Now these are going to want to jiggle and bounce around. So I'm just going to come in, I'll apply the heat, and that will just solder on. There we are. One side done. One piece of tape here. Should have done this first. Sorry. Okay. There we are. And we'll keep them from dancing quite so much. All right, so now that that's one side's done, I'm just going to come over and do the second one. So what we've done here is simply join the negative to the negative, and now what we need to do is the reverse and do the positive to the positive. Same process. I just need a bit better balance. Flux. Okay, don't be shy with the flux. It is your friend. This shouldn't take nearly as long to do the positive. It should take a little heat to warm up. And you can see right away that it's just significantly faster than the negative. And there you go. Oops. And again, now we just need to put that aside, and we'll tin up the connector that's going to go across. So there we go. Nicely tinned. Come back, grab this. I just need this to be a little bit more stable. This is not the ideal way to be doing that. And again, I'm just going to put these on. In fact, I'm going to kind of do it one at a time. Like this. Just melt it in, or solder it on, or whatever you want to say. There it is. Be my friend here. Just, there we are. Thank you. Yeah, good. Smooth that out a bit. There we are. So, what we have managed to do here is join two cells in parallel. And so what this basically is still a single 4.2 volt, whatever, you know, it's a single cell, but it's got double the capacity. Now, you don't need to watch me do that for all of the other ones, so I'm going to stop recording that. I'm going to get the other 3 pairs set up like this, and then we'll come back and take a look at how we actually join them all together. So we'll see you in a few minutes after I've done that. I've got all of the cells now soldered together into 2-cell parallel packs. So this is a single 4.2 volt lithium ion cell, but in parallel. So we've got them going from the first cell down to the 4th cell that we're going to be putting in series, and we've got them lined up from positive, negative, positive, negative, positive, all the way through. And I've written that on there so we can sort of see it and make sense of it. And if we bring in the multimeter, yeah, look at that. It's hovering right there at 13.59. It's a great storage voltage for these in series. And so we know that they're all connecting and showing the right kind of voltage that we need. In order to finish the battery pack, we've got to do a couple of things. Of course, we're going to have to rearrange this into the shape that's going to be appropriate for fitting into this wing that I'm putting it in, this AR Wing Pro. And you would need to do the same for whatever you might be putting yours into. And we will also need to, of course, connect the connectors, because there aren't any here right now. We're going to use, in this case, an XT60 connector, so it'll go from the positive end to the negative end, and clearly this is too short in this kind of a layout. That's what we're going to end up changing here in a minute. And we will need to connect our balance lead. The balance leads always have one more wire than the total number of cells, and basically it will go, the red will start at the positive, the next wire goes to the first intersection, the second wire goes to the next intersection, the next wire goes to the next intersection, and then the last wire goes to the end of the whole pack. The outermost wires will give you the voltage for the whole pack, and then each pair of wires gives you the voltage for an individual cell. Now, I've got another video that I made that explains this in much more detail, so if you want to learn a bit more about that, go ahead and take a look at the other video. I'll probably link it in my in the description below. Obviously, this setup here doesn't fit because these cables are too short and whatever else. So what we're going to do is rearrange this into the shape that I need for my particular flying wing. When we rearrange the order of these, we simply need to make sure that we're retaining the contact points in the same order. In this case, what I'm going to do is make this into a cube, and to do that, I would like the positive to be at the top. This is the very start of the battery pack, and it's where the positive from the XT60 will be. And so if this is at the top, here's my negative. These two need to connect together. So all I need to do is make sure that they're close together. So that will be that connection. Now this and this need to connect together. So I will put it up here and we can make that connection. And this one was connected to over here. And so all we need to do is maintain that connection. And if you take a look on here, they're not going to stand up so straight because of all the solder, but you'll see that we start with a positive, negative, positive, negative. And basically it starts here, goes down, cross to the next cell, up, cross to the next cell, down, cross to the next cell, and the battery ends. Our XT60 will start here and end here. And what we will need to do is make the correct connections between each cell in order to maintain the series flow. And what's really nice about doing it this way is each of these is one cell. That means that all of this is positive and all of this is negative. And so we can make the connections across wherever we need to. So what I'm going to do, just for simplicity, is I'm going to do the connections on these two first. It's because they're single connections, and then we will do the others. I need to make a connection on this side because the current is going to flow from the start of my battery through here. And so I will need to make the connections on this side between these cells. And because all of this is negative and all of that is positive, I can make the connections basically anywhere I want. Now, because this is going to be a power pack where I'm going to be using and asking it to provide quite a bit of current all the time, what I'm going to do is I'm actually going to make a double connection across from both cells, and that will make ample place for current to flow, and will also give us another place for us to attach the balance lead, because we'll need to put a balance connector in here. So to do that, and to help keep everything square and stable and straight, I'm going to first tape these two together, and then I'll get into the soldering. A little bit of fiber tape. Now you want to keep the cells as square to each other as possible. And so, as we were saying, cell number 1, this is the part, this is where the XT60 is going to come down. So what we need to do is make the connection between cell number 1 and cell number 2. And so we will be doing it right here. Now, I like to have these fairly stable, so I have a very small vise that I'm going to use, and it will hold the cells very gently. And it just keeps everything square and tight and not moving around. So I'm going to do that quickly, and once I'm done with that, we'll come back and take a look and see what it looks like. Now I have finally finished the soldering to put these parallel cells into series. Cell number 1 connects over to cell number 2. At the top, cell 2 connects to cell 3. At the bottom, cell 3 connects to cell 4. And then we get the negative out. So let's just do a quick check on the multimeter here. From the positive end to the negative end, we get this 13.56 volts, 55. What we need to do is solder on the XT60 connector that's going to be the power lead for the pack, and also the balance leads. And this is the part that might get a little tricky, but you have one wire that's at the beginning, one wire that's at the end, and then the other ones just go to negative terminals. This is basically how it works. We'll do the little leads first here, and I'm just going to do those in the middle of the solder pad. Pad right here. I'm just going to do the one for now. There we go. That's good. And so for this, all I need is to put the positive on here. There we are. So that's that. The next one, which is this minus, needs to go right here on the first cell. And that will just tell us the voltage of that very first cell. There we go. Perfect. And so lead number 2, that's where that one's gonna go. Right there. Tweezers. This is gonna get hot. Just tag that one on. There we go. And now, if we were to measure the voltage between these two, we would get 1 cell voltage. So now we just have to keep going with these. So the next one will go from this to this. You know what? I am going to come back and trim that positive. That was a mistake. So we'll go to about there. Don't make a mistake of, grabbing this, or I'm going to put it down, putting it on top. That would be just like, when you're doing these lipo things, lithium ion things, always think about what you're doing. Get the spot ready. Just a tick more. There we go. All right, and this to here. There we are. Okay, so that's good, that's good. So here will be the next negative terminal, and we will put it on here. So keeping going in the correct order, the third wire should go to the third junction. comes. Those guys out of the way. Tweezers so I don't burn my fingers. And away we go. There's that. Just pull that back up through a bit. There we are. And then the very last one goes to the negative terminal. And it doesn't need to be super, super long like the others, so trim it down, tin it, and then we'll just double check that everything is in exactly where it should be. Alrighty. There we go. That's good. Take this last lead, and there we go. So here we have the basic pack now with all of the leads put on it, with the exception of the main power lead. And since that's the last one we're going to put on, what I'm going to do for now is cover up a lot of these exposed parts with capped on tape, which provides an electrical barrier. I'm just going to go completely across that whole section. And that will be completely isolated. Now I'm going to need a negative and a positive to connect my XT60 on, and so that's what I'll be doing here, but all of the other ones I can cover and should cover with this tape. After, I'll come back and I'll cover up the rest of it as well. Okay, we'll go back and we'll do the bottom. Now that is nicely electrically isolated. Those parts are all kept well apart from each other. So now we need to do the XT60 connector onto here, positive to positive, negative to negative, and then we'll be good to go. So I'll get these wires tinned up, and we'll see how it finishes off. So those are ready. Yep. And now I just need to do this soldering. XT60 to here and here. So that's what we'll do. Right, that went on quite nicely. A little bit of flux again. Get this heated up because this is the negative side. It'll take more heat. You don't want this to be a cold solder joint. So make sure you get this part heated up before you even worry about the wire. And then we will bring this over. And ask it very nicely to participate in our festivities. That's going to need a little bit more fresh solder on there. There we go. Yeah, much nicer. All right, and that's it. It should be done, except for wrapping it and making it safe. So let's just do a check and see that it is. Voltage is on. Try to put the positive in the positive, the negative in the negative. Or 13.5. There we are. Settled down a little bit over the time I've been working on it. So now what we need to do is finish off this capped on tape on these other parts that are still exposed. Jump that across. And there you go. For all intents and purposes, that is a usable battery pack, and you could take that off and use it. Now it is better to put a little bit extra protection on this for some safety. What I would like to use is a really thin foam that comes with our packing, that comes with a lot of our electronic stuff that we order. I don't happen to have a piece of that kicking around, so instead, this is the stuff you put on the floor to keep your carpets from slipping around. And it's foam, and it'll just, all I want to put on here is just a little bit of something that'll act as a bit of cushion. And so that's what this will be. I'm just trying to see the right dimension. Perfect, that'll work. So I'll just sort of fold this. It'll kind of go right over where all of the solder joints are, just as a little bit of extra cushion. And then I'll just fiber tape it on. And really, it just needs to be some thin foam on there. whatever you might have would work. Where are we going here? From there across to there. On the top, I'll do the same thing on the bottom. Fold over, hold on, over you go, and around you go. All right, so that's the only protection that I personally would like to put on, is just right over top of the soldering joints in that area. Beyond that, if you want to add a little bit more, some people put foam around there, that would be entirely your choice. Of course, everything else you add to it will make it heavier. You can get shrink wrap that's this big. It's quite expensive, and usually it's quite heavy too. So that's another option if you want it. But for me, I'm just going to use fiber tape to sort of seal everything off, and it will be plenty strong enough, and it will be sufficient. That's what I'm just going to do now. Line it across the top. Fold it over, and then a piece through the middle again to cover everything. And we'll do the same on the other side. And that should be that. One piece there. Piece across here. Oh, somebody's home. My dog's yowling. All right. So because the dog started yelling, I think I'm going to stop recording here.